بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول درس جديد في مادة الاستاتيكا وهو تمارين على الاتزان. طبعا احنا عارفين general equilibrium دي very important lesson. قلنا الايكوليبريم under forces or different forces, coordinate forces, we can know or we can determine the coordinate forces like or unlike. Welcome my dear student in our math program for secondary 3. Today we are taking the lesson a static subject. It's called exercise about equilibrium. Look at the first example. Exercise about equilibrium. Example number 1. A uniform rod means weight act at its midpoint of length 8 cm. If the rod is placed in horizontal position on two supports at its end of the rod carries two weight. The first weight 5 Newton act at a point distance 60 cm from A, and the second 20 Newton act at a point of distance 5 cm from point B. If the value of reaction at B is equals to double reaction at point A, find the weight of the rod and the value of reaction at A and B. Solution. Look at, my dear student, in this example, the unknown weight of the rod. Uniform rod. This uniform rod AB, which we have to support the first at A, its reaction R, the second support at B, its reaction double R. Look at, my dear student, when we solve this example, we have two unknown, W and R. We need two equations. The first equation, R1 plus 2R2 or R plus 2R minus W minus 5 minus 20 equals 0, or R plus 2R equals W plus 25. Therefore, we deduce that 3R minus W equals 25. This equation number 1. W equals 3R minus 25. This relation between weight and reaction. Remember, my dear student, we have two unknown. Two unknown, W and R. We need other equation. We must find moment at A or moment at B. Look at, my dear student. Moment at A, summation this theorem, moment of forces about any point equal the moment of resultant at the same point, or summation of moment at any point must be equal 0. Therefore, when we find moment at A equals 0 by using, look at, by using 2R multiply distance 80. Distance 80, this distance equals 20 times 75 plus 5 times 60 plus W times 40. My dear student, look at, when divided by 10, we deduce that 4R equal 80, R equals 20 Newton. The value of R. Then reaction at A equals 20, but reaction of support at B equals 2 times 20 equal 40. Therefore, by substitution to find the value of weight equals 35 Newton. We say that the reaction at support A equals 20 Newton, at B equals 20 times 2 equal 40 Newton. Another example. A page of length 30 meter and its weight 35 ton weight act at midpoint. Rests on two supports at its end A and B. If a car of weight 3 ton weight is moving on the bridge, find the pressure of each of the two supports when the car is at 10 meter distance from A. This example very important. Also find distance between the car and the end A when the pressure equal 9 over 10 at B. Solution. Look at this bridge AB. The bridge AB distance equals 30 meter. 30 meter. We have two support at two ends, at A and at B. At A B1, at B B2. Reaction at A B1, reaction at B B2. Look at, my dear student. The bridge, its weight 35 ton weight. Also, a car, its weight 3 ton. Then we reduce that, my dear student. The forces down 3 plus 35. The forces which act or summation of two reaction of two supports B1 plus B2. Therefore, B1 plus B2 equals 38. We need that, my dear student, other equation to calculate the value of B1 or B2. My dear student, we know that B1 plus B2 equals 38 ton. What is the value of B1? What is the value of B2? Then we need moment at A or moment at B. Moments at A must be equal 0. How many forces? The 3 forces. We have 3 forces. 3 weight of the car, 35 weight of the bridge, and B2 reaction of support at point B. Therefore, by using the summation of moment, negative 3 times 10, negative plus negative 35 times 15, plus B2 times 30 must be equal 0. Therefore, we deduce that 30 B2 equals 30 plus 525. Then B2 in this case equals 18.5 weight. By using subtraction, B1 38 minus 18.5 equals what? 19.5 ton weight. Then we find value of reaction of support at A equals 19.5. Reaction of support at B equals 18.5. Look at, my dear student. Find the distance of a car X. The car X at from distance at A if the pressure or reaction of support at A equals 9/10 of support at B. We know that the two forces up equal two forces down. 9/10B plus B equals 38. It is easy to find the value of B. What is the value of B, my dear student? Equals 20 ton weight. After that, we calculate the moment at A. Must be equal 0. How many forces? 3 forces. To calculate the moment at A, we need 3 forces, 35 and 3 and B. But direction of the moment of 35 and 3 is negative, B is positive. My dear student, we deduce that B times 30, distance between A and B, equals 35 times 15 plus 3 times X. Remember, we can calculate the value of distance between a car and the point A by using substitution about B. Therefore, my dear student, 3x equals 30b minus 35 times 15. 3x equals 20 times 30 minus 35 times 15. 3x equals 75. Then x equals 25 meter. Then we deduce that when the car reached at a distance 25 meter from the point A, the pressure of the A point A equals 9/10 the pressure of B. Understand, my dear student? If the pressure or reaction of support at the point A 9/10 of the reaction of support at B, the distance of the car equals 25 meter from A. And don't forget, the length of the bridge is 30 meter. Or someone say the car at a distance 5 meter from the point B. It's okay. The car at a distance 5 meter from B, or at a distance 25 meter from A. This right and also this right. Understand? Remember, my dear student, this example, we say that in our life, each day, in the bridge, if the bridge 30 meter, if the weight of the bridge 35 ton weight, and the car its weight 3 ton weight, this car, which its ton 3, its weight 3 ton weight, at a distance 25 meter from the starting of the bridge, 25 meter, when the reaction of support of the first end A equals 9/10 the reaction of support at B. Remember, my dear student, this example very important to calculate the pressure of each support and the distance of the car and from one of two ends of two supports. The car will arrive at 25 from A. Another example. AB is a rod length 120 centimeter. It in equilibrium when it rests by its end A the ground, and its other end B is raised up under action of force magnitude 72 Newton acting vertically upward at 0.20 centimeter distance from B. It is also in equilibrium if its end B rests on the ground and the end A is raised up under action of the force magnitude 84 Newton act vertically upward at A. What is the required? Find the width of the rod and the distance of each point of action from E. Solution. Look at the first case. AB is a rod. Look at, we have reaction at A, R1. The weight is W. Distance, this AB inclined with horizontal with angle alpha. We suppose AD equal X. Therefore, moment about A, W times AD. What is the length of AD? AD equals X cosine alpha. Equals this moment, W times AD, we have two forces, W and 72, opposite direction. W times AD equals 72 times AC. We suppose, my dear student, AB equals what? Or AC, the distance AC 100 cosine alpha. The distance. Why? Because AB equals 120. Therefore, when calculate AC from the opposite figures, AC over 100 equal cosine alpha. Also, AD over X equal cosine alpha. Therefore, we have 2 or 3 unknown. We have 3 unknown, cosine alpha and X and W. We divided each term by cosine alpha. Then the first equation, Wx equals 7,200. The second case, my dear student, the rod in equilibrium or rest at when B on the ground and A put in vertical wall, then we have R2 act or reaction support at B. Therefore, we deduce that the weight of the rod W at a distance from AX, then from B 120 minus X. Why? Because AB equals 120. Look at ACX, therefore BC equals 120 minus X. We calculate moment at B. Therefore, we have two forces, 84 and W. W times BE equals 84 times BK. Remember, my dear student, BE equals 120 minus X cosine beta. But BK equals 120 cosine beta. By substitution, therefore, divided each term by cosine beta. Therefore, we calculate the second equation or relation between W and X. 120W minus WX equals 84 times 120. Therefore, by substitution about what? 100 WX. Therefore, my dear student, look at with substitution, therefore W equals what? Equals 84 plus 60. 84 plus 60 equals what? Equals 144 Newton. Therefore, my dear student, X times 144 equals what? 7,200. Therefore, X equals, divided each term by 144, X equals 50 from the A and A. The value of X from A and A equal 50 centimeter, or from point B 120 minus 50 equals what? Equals what? 70 centimeter. Then, my dear student, in this example, we calculate the value of X and the value of W. Another example. AB is non-uniform rod of weight 8 kilogram weight. What is the meaning of non-uniform? Excellent student. Its weight don't act at midpoint. Length is 120 centimeter. We have C and D, 2 points on the rod where AC equals CD equals DB equals 40 centimeter. The rod is suspended horizontally by 2 vertical spring balance from C and D. If the rod is in equilibrium when the reading of balance at C equals 3 kilogram weight, find the distance of the center of gravity of the rod from A and the weight of magnitude suspended from a point on the rod. Find distance from A if the reading of balance C becomes 4 kilogram. Look at, my dear student, we have AB, this non-uniform rod equals 120 centimeter. We have 2 support at D and C. D T1, this reaction of support, also at C3, but its weight E at E is 8. Summation of R, or resultant of all forces, must be equal 0. Therefore, 3 plus T1 equals 8. Value of T1 equals 5 kilogram weight. Therefore, moment at point C to find or to calculate the value of X. T1 times 40 equals 8 times X, or minus 8 times X equals 0. Therefore, 5 times by substitution about T1 equal 5. 5 times 40 equals 8 times X. Therefore, X equals 25 centimeter. Then the value of X, 25, or the weight at distance 25 from C, or 15 from D. Why? Because CD equal 40 centimeter. Then we reduce that, the value of reaction of support at point D and the value of X. My dear student, In equilibrium, we know two types of equilibrium. The first, when the rod is uniform, and the second, when the rod is non-uniform. The rod is uniform, we know that its weight acts at midpoint of it, but when the rod is non-uniform, its weight not act at midpoint. Remember, my dear student, when we have two supports or more support, each support has reaction. This reaction must be up, but weight it's down. When we find the value of each support and the distance, we need two equations. The first equation, always we use summation of resultant of all forces must be equal 0. Then we find the moment of any point of the rod must be equal 0. Don't forget the direction of moment. We have two directions. Positive direction anti-clockwise, negative direction clockwise. Don't forget also, my dear student, the reaction of support, sum of reactions equals sum of weight or the weights downward. Forces up equal forces down. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.